welcome. This is Dr.BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In today's session, we will be learning about the center of gravity, centroid, and difference between center of gravity and centroid. The outcome-based education regarding today's topic, course outcome is identify the centroid and center of gravity for a simple and composite plane sections from the first principles. Topic covered would be Introduction to Centroid and Center of Gravity. And topic learning outcome is understand the concept of centroid and center of gravity involved in practical engineering problems. First, let us understand what the center of gravity means. All the rigid bodies are made up of each and every large number of particles, and each particle will be attracted towards the earth. If you assume a body, it would be made up of many number of small particles. So all these particles will be attracted towards the earth. And the gravitational forces of particles, each and every particle which are acting vertically downwards, are parallel in directions. All the gravitational force lines or directions which we consider for each and every particle, we can consider that all the directions would be parallel to each other. And the resultant of all these parallel gravitational forces is called as the weight. And this weight will act through a single point. As we know, the resultant is a force which replaces all the forces in the system. If we consider this resultant as a single force, which is the resultant of all the particles forces that is acting vertically downwards, then the resultant is termed as the weight. And the point where the resultant is acting, nothing but the weight is acting, it is called as the center of gravity. So it can be treated as the point through which weight acts or weight is assumed to be concentrated is called as the center of gravity. And the center of gravity is independent of orientation in space. That means the mass of the object or any mass or any object that is in the space, it is the independent criteria of the center of gravity, even though the mass or object is in any condition or any orientation. So let us consider this body which is having each and every particles that is made up of all the particles, and all particles will be attracted towards the earth. As we are seeing, all the forces directions, the gravitational pull directions will be vertically downwards, and all the particles will have parallel forces. And the resultant of this, all the forces that are acting vertically downwards, and it acts at a single point, and that point is termed as the center of gravity, and the resultant force that acts at that center of gravity is called as the weight of the object. If at all the center of gravity of a plane figure is considered, like a two-dimensional figure is considered, which is having uniform thickness and homogeneous material, the total material of the object is homogeneous and the uniform thickness of the material is considered, then the centroid is the term used for the concentration of the area, right? So all the particles that are made up of the object, the two-dimensional plane, all the particles forces will be acting vertically downwards, the gravitational pull, and the resultant of all these gravitational pull forces is termed as the centroid. The center of gravity is for three-dimensional objects, the orientation, in any orientation it is the same. Similarly, for the two-dimensional objects, centroid is the term used for the point from where the total area of the section acts. For understanding this, let us see a small animation. Let us consider an object here which is made up of so many particles as shown in here, and each and every particle's gravitational pull will be acting downwards. Each particle is attracted towards the center of the earth with a force equal to its weight, each and every individual particles. So let us consider the forces are F1, F2, F3 and F4, F5 and so on. For each and every particle, the forces are given like this at the points P, Q, R, S, T, U. Then all the forces will be acting vertically downwards because of the gravitational pull. And the resultant would be F is equal to F1 plus F2 plus F3 plus F4 plus F5 plus F6. As we know, the resultant how to evaluate. And all the forces resultant is termed here as F, which is acting at a point G, which is treated as the center of gravity. So the center of gravity is defined like this. The point through which resultant of the gravitational force, that is weight, acts for any orientation of the body. Let us consider an object having number of points, and this orientation we are considering with respect to the x-axis and y-axis. We are considering the x and y-axis as the reference lines and reference lines for the points which are available in the object. So all the points here, let us consider 2 points which are having the weights W1 and W2, right? And the resultant of these two weights, W1 and W2, is W, as shown in the figure here. And the distances of these points, from the reference axis, the W1's distance is x1 from y-axis and y1 from x-axis. The W2's distance from y-axis is x2 and x-axis is y2. And the distance of W from y-axis is x bar and x-axis is y bar. So center of gravity can be determined by applying the principle of moments for the particular figure which is shown here. Weights of individual particles, right? So the weights of individual particles which we are considering are W1 and W2, and the coordinates for these particles are x1, y1 and x2, y2. Then coordinates of resultant gravitational force W are x bar and y bar. According to the Varigton's principle, moment of resultant is equal to the sum of moments of all the forces acting in the system, right? So when we apply this, taking moments about y-axis, we are considering the y-axis as the reference moments, and we are taking the moment formula for the figure which is given here. So the resultant W into x bar is the distance. So force into perpendicular distance. So that is W into x bar is equal to W1 x1 plus W2 x2, where W1 is the force and x1 is the distance of that force, perpendicular distance, and W2 is the force and x2 is the perpendicular distance of that particular point from the reference axis. So the position of center of gravity from y-axis, if we consider the position of center of gravity from y-axis, that is x bar, that would be given by W1 x1 plus W2 x2 by W. So it can be written as sigma Wx by sigma W. So number of points or number of particles that are being obtained or considered by the object, we can do the summation of all the forces or all the weights of each and individual particles, and then the denominator will have the summation of all the weights. Since W is equal to mg, where we know mass into acceleration due to gravity, the above equation can be written as x bar is equal to sigma mx by sigma m, right? So as acceleration due to gravity is constant, we can remove that from numerator and denominator, and it can be written as sigma mx by sigma m. So for homogeneous solids, if we consider the material of the solid or object which we are considering is homogeneous, then we can write mass is equal to density into volume. So this can be written in the place of mass here from in the above equation. X bar is equal to sigma rho Vx by sigma rho V. So from this, as this is a homogeneous material, density will be same in the numerator and denominator. So it will be converging into sigma Vx by sigma V. Similarly, the position of center of gravity from x-axis, it can be written as y bar is equal to W1 y1 plus W2 y2 by W. That is equal to sigma Wy by sigma W. As you have seen in the previous points or previous equations, the equations would be similar. That is equal to sigma my by sigma m, right? So in this way, in terms of volume, the distance of center of gravity from y-axis can be treated as sigma Vy by sigma V. If you observe carefully, the distance of the center of gravity from y-axis is x bar and from x-axis is y bar. So x bar and y bar are the coordinates of the center of gravity. So when a problem is been asked for you to identify the centroid of the particular object or centroid of particular section, then what you need to do is you need to identify the coordinates of the centroid, that is x bar and y bar. Nothing but the distance of that centroid from the reference axis. This is not a standard thing that the axis will be lying at the same position or it's at a particular distance, right? we will be assuming a reference axis. We will be assuming a reference axis and we will be calculating the center of gravity. So keep it in mind while solving any problems, you need to take a reference axis first, right? That we will learn anyway when we are going to calculate the problems. So for the identification of center of gravity, there is a small animation here. You can observe here. When a cardboard is placed on a finger, when you try to balance a cardboard using a single finger, then the center of gravity or the center point of the object is being anonymously identified such that the balance will be stable. So center of gravity is the point through which the resultant of weight of all particles of the body acts. When we consider this, when you try to rotate or when you try to move the two-dimensional thing or any three-dimensional thing, for identifying the center, there is a small procedure where we can, for any orientation of the object or any shape of the object, we can identify the center of gravity as that will be shown here. Using a retard stand and object, what we are doing is we are placing P, Q and R points, and we are identifying the intersection point of these things which is acting vertically downwards, right? So all the vertically downwards directions will be identified in such manner, and the intersection point of all these vertically downward directions will be taken, and that would be your center of gravity. As shown here, we will be marking at each and every point like P, Q and R, each and every point we will be taking the vertically downwards direction lines, and the intersection point would be the center of gravity. Here, there is a small concept for an example for understanding the center of gravity. What happens if the center of gravity, it depends on the orientation of the object, which we have already considered. We have already considered that the orientation of the object is independent, right? Center of gravity will not move, will not change. But what happens to the stability of the any object when the deformation or change in the position of the shapes will happen? For same object, when the shape changes, when the shape changes or the position of the different parts of the object changes, what happens to the center of gravity? That we can see here. There is a small example here. Consider a forklift which is used to lift weights from the platform, right? You can see here the animation where this forklift will be used to lift the weights. This yellow ball which is being shown here, that is the center of gravity of whole mass that is being seen here. Because of the load acting there, which is acting there, the center of gravity of this particular vehicle, we can say forklift, that is moving forward, right? Initially, when the load is not present, then the center of gravity of the vehicle is at particular position. When the weight is changing or the orientation of the shape is changing, the center of gravity is changing as per the change of the shape here. You can observe here carefully. And this triangle which is being given, the trapezoidal form of the triangle which is being given here, it is called as the stability triangle. When the center of gravity is lying inside the stability triangle, there is no problem. The vehicle will be in stable position. When the stability triangle exceeds, that means the center of gravity exceeds this stability triangle, then the stability of the vehicle changes and the vehicle may overturn. So that is about the center of gravity. Now let us see about the centroid. As we have discussed previously, centroid is defined as the point where the whole area of the plane figure is assumed to be concentrated. The weight may be expressed as W is equal to specific weight into volume. This is a general expression for a weight which can be given, that is specific weight into volume. The specific weight omega can be written as density into acceleration due to gravity, and the volume term we are taking it as area into thickness. As the thickness is similar, thickness is same for the total section which we are going to consider, the plane figure. For homogeneous materials of uniform thickness, density and thickness are constant. Therefore, the weight is proportional to the area. Thus, the position of the centroid of lamina or plane figure from y-axis is given as x bar is equal to a1 x1 plus a2 x2 by a, where A1 and A2 are the areas of number of laminas which we are considering, and the equation is written as sigma AX by sigma A. So x1 and x2 are the distances of each and every lamina which we are considering from the reference axis again. Similarly, the position of centroid from x-axis can be taken as y bar is equal to a1 y1 plus a2 y2 by a. So that is equal to sigma ay by sigma a. So in this way, we can evaluate, or we can identify the centroid of any section. So centroid and center of gravity, there is a difference. Center of gravity will be considered when the mass of the object is considered, or it is for a three-dimensional object, and the centroid is for a two-dimensional plane or two-dimensional sections. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.